Hi everyone, it's the Math Sorcerer here with Chegg. In this video, we're going to discuss Lagrange multipliers. Let's do this example. Find the extreme values of f of xy equals x squared minus y squared plus 1, subject to the constraint x squared plus y squared equals 4. Let's carefully work through this solution. So when I'm doing problems with Lagrange multipliers, I like to write down the conditions every time because it makes the problem easier, I think. So we have two conditions. The first is that the gradient of f at xy is equal to lambda times the gradient of g at xy. And the second condition is that g of xy is equal to c. So these are the two conditions that we have in every single Lagrange multipliers problem. So step one is to write them down. In this particular problem, g of xy is given to us. It's equal to x squared plus y squared. And we know that because it's right here. See, x squared plus y squared, and our c in this problem is 4. So c is equal to 4 in this case. So here c is 4. And so we have x squared plus y squared equals 4. In other words, g of xy equals c. Okay, so now let's find the gradients. Recall that the gradient of f is just the vector whose components are its partial derivative. So I'll do it over here just so you know the formula. The first component is the partial with respect to x, so fx. The second one is the partial with respect to y. So the gradient of f is equal to the vector whose components are fx and fy. All right, so now we're going to go ahead and actually compute those gradients. So I'm going to go straight from this top line here. We're just going to compute gradients. So we're taking the partial of f with respect to x. So f is x squared minus y squared plus 1. So when you take the partial with respect to x, all of the y's are constants. So the derivative of y squared is 0. So we're just going to get 2x for that first partial. And the partial with respect to y, in this case, the derivative of x squared is 0, and also the derivative of 1 is 0 because it's a constant. So we just get negative 2y. So again, the partial with respect to x is 2x because everything else is 0. The partial with respect to y is negative 2y because everything else is 0. Equals lambda. And then now we're going to take the gradient of g. So g is even easier. The derivative with respect to x is 2x. And the derivative with respect to y is 2y. And again, that's because when you differentiate with respect to x, all of the y's are constants. So the derivative of y squared is 0. And likewise, differentiating with respect to y, the derivative of x squared is 0. So we have two vectors and they're equal. Let's go ahead and set their components equal. I'm also going to multiply this through. Maybe I'll do that first. 2x minus 2y is equal to, I'm going to write it like this, 2 lambda x 2 lambda y. So now two vectors are equal, so their components are equal. That tells us that, I'm going to write it over here, 2x is equal to 2 lambda x. That's equating the first components. And equating the second ones, we get negative 2y equals 2 lambda y. Beautiful, really nice. So now something cool happens. Let's maybe solve the first equation here, see what happens. So I'll subtract 2x from both sides. So we get 2 lambda x minus 2x equals 0. Looks like we can pull out a 2x. So let's go ahead and do that. Let's pull out a 2x here. So we get 2x parentheses lambda minus 1 equals 0. A product equal to 0. So 2x equals 0, or lambda minus 1 is 0. By the way, the algebra in these problems gets really crazy sometimes. So it's always different. You just want to play with it and see what happens, which is what we're doing here, right? I subtracted, factored, it's equal to 0. We set each factor equal to 0. Divide by 2 here, you get x equals 0, or add 1, you get lambda equals 1. So let's think about what's happening here. And in order to really understand the next few steps, I'm going to write down our condition again. So our condition was x squared plus y squared equals 4, because usually you have to use that now in the problem, okay? When you're trying to find lambda and x and you're messing around with the equations, you have to use your constraint. It's really important to always think about it. All right, so we have x equals 0 or lambda equals 1. Let's think about this. If x is 0, well, we can plug 0 into our constraint. So we're going to get 0 squared plus y squared equals 4. That means y squared equals 4. Then you can take the square root of both sides and you'll get a plus or minus. So y is plus or minus 2. So if x is 0, you can plug it into your constraint. You'll get y squared equals 4. Take the square root of both sides. You get y equals plus or minus 2. So we have two ordered pairs here. We have 0, 2 and 0, minus 2. So we're going to use these at the end of the problem to figure out the max and min. That's not the answer, but they're important. The other case is if lambda equals 1. So if lambda equals 1, let's think about what happens here. Well, if lambda is 1, look at this equation here. Negative 2y equals 2 lambda y. That actually becomes negative 2y equals, well, lambda is 1, so it becomes 2y. This means that y equals 0. This is impossible. Negative 2y can't be equal to 2y. If you're not convinced, you can add 2y to both sides. And then you get 4y equals 0. Divide by 4, y equals 0. So if lambda is 1, y is 0. Oh, and then we can take the 0 and plug it into our constraint. So we would get x squared plus 0 squared equals 4. So x squared equals 4. Just like before, take the square root. You get a plus or minus 2. So very, very similar to what we just did. So we would get two ordered pairs here. Y is 0, x is plus or minus 2. So we get 2, 0, minus 2, 0. So we have 4 different ordered pairs. So now what we're going to do is we're going to take these numbers and plug them back into our original function. So our original function was f of xy equals x squared minus y squared plus 1. And so now we just take every single one of these ordered pairs and we plug them into the function. The biggest answer we get is the max, the smallest is the min. So let's just go through it. So let's do f of 0, 2. That's going to be 0 squared minus 2 squared plus 1. Minus 4 plus 1, so minus 3. And then if we do 0, negative 2, it's going to be exactly the same, right? It'll be 0 squared minus parentheses negative 2 squared plus 1. Negative 2 squared is 4, but we have a negative, so it's negative 4 plus 1, so it's negative 3. And then if we look at f of 2, 0, in this case, we're going to get 2 squared, right? 2 squared minus 0 squared plus 1. So we just get 5. 4 plus 1 is 5. And then f of negative 2, 0, we're going to get the same thing. Negative 2 squared plus 1 equals 5. So we have the answers now. Let's write them down. So we have that the min is the smallest number, negative 3. That's the minimum. And it happens at, so it occurs at two different places, 0, 2 and 0, negative 2. So at 0 plus or minus 2. Sometimes if you're taking a class or something and you're doing like online homework, a lot of the online homework systems will want the ordered pair. And then the max is 5. It's the biggest number. So just the biggest one you get is the max. That's the max. And it occurs at two places. It occurs at 2, 0 and negative 2, 0. So plus or minus 2, 0. Wow, really intense problem. And that's something that needs to be said. These problems are all pretty intense. This is a moderately easy problem, so these problems can get harder. And the difficulty level will vary. It just depends on how hard it is to find your lambda and your x and to see what happens. But the main thing to remember is when you're doing this problem, you want to start with these two equations and then go from there. I hope this video has been helpful to someone. If you enjoyed this video, make sure to check out more videos on Chegg. Until next time, good luck and take care.